Hey guys, welcome back to Zeus Tech. So today in this video, we're going to be learning about how to make a logistic regression model inside of Python, okay? So before we begin, I'd like to say I'm sorry for leaving for some time. I have been really busy, but hey, maybe this can be me starting to post again and giving you guys good important lessons about Python and like technology in general. Okay? So the first thing we're going to do to make our logistic regression model is that we're going to first have to import a few things. So we're going to first import pandas as PD, import numpy as np, import sklearn.linear model. No, sorry, from sklearn.linear model, import logistic regression, and then from sklearn.model selection, import train test split. Okay, and then from sklearn.metrics, import accuracy score. Okay, so now that we've gotten all this, we're gonna run it. No errors, so we can continue. So these are all the libraries you have to import. For pandas and numpy, they are already in here. That when you get collaboratory or when you get anacondas, I'm sorry, if you get Jupyter Lab, I'm using Jupyter Lab. That's already in it. But to actually get sklearn, you're gonna have to pip install it. And if you guys want a tutorial on how to do that, let me know in the comments below and I'll be glad to help you. And also guys, so I didn't mention this before, but to do this, I would recommend you either use Collaboratory. If you don't know how to get there, then check out my video. It should be in the top right corner right now. So check that out and check that video out to learn how to open up Collaboratory. Or you can use Jupyter Lab. The problem with Collaboratory is that to actually get the data, you're gonna have to upload it to your Google Drive. While in Jupyter Lab, you just have to get it in your File Explorer, this, and then after that you're able to use it. So that's why I recommend using Jupyter Lab, but up to you. So now after we have gotten our libraries imported, we're going to then get our data. So df equals pd dot read, and for here you either need to have a CSV file or XLS or XLSX file. So XL or CSV file. Okay, CSV stands for comma separated values, and XL, you guys probably already know what that is. And the reason for that is that the function that we're using is either going to be read CSV or read XL. I have a CSV file, so we're going to be using CSV. And to learn how, and if you guys don't already have data, let me know, and you guys want to learn how to get that data, let me know in the comments below again, and I'll show you guys how to I'll show you guys how to get data needed to make a logistic regression model. But I'm pretty sure that if you're watching this video, you already have the data, but you just need to learn how to actually make the model. So then we're gonna get your File Explorer address, and to get this, you just have to go to your File Explorer and see the pathway that you want to actually get your file. So for me, it's from my C drive to users to my name to downloads, and inside of downloads, here it is. Okay, and now we're gonna quickly read the data. So df.head can read the data, and df is the name of the variable that we're storing the data in. And you can see here that we have this data. So let me separate it into two values. This part, this is x, this is y. Okay, x is all the data except for the result. Y is the result. So x is all the data that changes the result. So y is dependent on x. because without x there can't be y, but x is independent because even if y is gone, it doesn't affect x. Okay, you guys probably want to remember that because it's pretty important. So, and here we have the target. Target is just the result, and in this case 1 means yes and 0 means no. This is almost always how it is, remember, and it's important thing to remember. Okay, and in this case 1 means okay, you have heart disease. 0 means no, you don't have heart disease. Okay, so now we have this, so we're gonna create a new cell again, and then here we're gonna create our x and y values, and x, or as I said before, is this. So we're just gonna be splitting up the data into x and y. So we're gonna create our first variable, x equals pd.dataframe df.drop target axis equals 1, y equals df target. So for x we made a data frame that has all the values except for target. We have a drop target here, as you see, so it's everything except for target. And what y is just target, so all the values in target. Okay, so we're gonna run this, no errors, so we can continue on. And now that we have our values split up into x and y, we need to split it up again into training and testing. Okay, so the reason why we have to split it up into training and testing is that we want to keep like x train and y train, and so basically we're able to train the model, and x test and y test to be able to test the model. And the way that we're going to do that is by using train test split function. So first we have to create our variables, x train, x test, y train, y test. Okay, and that will equal train test split x and y, and down here we're going to specify a test size. Test size will be 0.40 to 40%, and random state will equal 33. So what is this? So as you see here, we're splitting up x train and x test, y train, y test, and we're splitting up x and y. So x will be split by 40%. 40% will go to train, 40% will go to test, 60% will go to train. And the reason for that is because I specified the test size is 40%. So 40% is meant for testing, 60% is meant for training. But what random state is that even though we do have training and testing how that is, we still don't want it to split at the 40% mark, because that will make, what if the data is that the top half, the top 60% half is just yeses and the bottom 40% is just nos? That would make us so that once we actually test the data, it will be completely messed up and will not work. So what random state does is that makes it so that even though we are still taking 40%, it splits up at random places or at a random state, hence the name. So now we're going to run this. We're going to create a new cell, and now we're going to actually get our logistic regression function in. Okay, this is how we're going to be testing everything. So we're going to name the function reg equals logistic regression. As you see, we imported it from here. So this is logistic regression. This is all the math, everything that you need, and like all the functions you need to actually use the file to actually make a model. So we're gonna run this, and we're gonna create a new cell. reg.fit x train y train. Now here, when I say fit, I actually mean we're gonna train the values. Okay, so this is where we're gonna train the logistic regression model, and we were able to save it because we put it into a variable. Okay, so we're gonna run this. A bunch of stuff's gonna show up, and now we know that it executed properly. Now here, what we're gonna do next is that we're going to then do ypred equals reg.predict x test. What this is that we're predicting the x values, so we're gonna give a y value from the x test values. So we're testing the model, and we're putting the answer, and we're putting the answers into yPredict. Okay, so we're checking out how we're gonna be, and yPredict is gonna have all the answers from this. And then we're gonna do print accuracy score will be metrics dot accuracy score. Oh no, just accuracy score. And then we're gonna put y test, y predict. And what it's gonna do here is that it's gonna compare the actual answers from y test from y predict. What we predicted from y predict is here, because we predicted the value here. This is the logistic regression working. And from x test and then y predict. So if we run this, the accuracy score is 81%. Okay? So we have officially just created a logistic regression model. Okay? And you can test run with these two numbers here. But remember, if you want to change these numbers, then you have to run this cell, this cell, and this cell. Okay? And you can see if you can get a better accuracy score by doing that. Okay? So I'll just show you a quick example. So what if we made the test size 45%? We gave more testing and less, or make it 30% actually. So more testing and more training, less testing. So let's run it. Let's run all the files again. And now if we run this again, you see it changed to 85% now. Okay, so this way you're able to test out your logistic regression model and see what works, see what's better and stuff. Okay, and with this you're actually able to like grow up and maybe make another and actually like get your own other files without target and predict that. So say that maybe if you've gotten like another data frame that has all the values except for target, so it doesn't have the answers but has all the other values. If you put this into predict, if you do print rgd.predict, it will give you the values. But that is for another video. If you guys want to see that, please let me know in the comments down below. And yeah, so that's gotta be the end of the video, guys. I hope you guys enjoyed it and learned something from this. If you have any questions, please let me know in the comments down below. And with that said, I'll see you in the next video. Bye bye.